Welcome to the Explainer. Today, we are going to slice right into the geometry of circles. We'll take a look at how these perfect shapes pop up in, well, everything, from a slice of pizza to the way a lighthouse beam cuts through the dark, and how a little bit of math helps us make sense of it all. I mean, just look around you. You've got a horse grazing in this perfect curved arc, or the sections of an umbrella. We see parts of circles everywhere. They're just fundamental shapes in both nature and how we design things.
So how do we actually measure these pieces? We can't just eyeball it, right? To answer that, we need to learn the language of circles. We need a geometric toolkit, basically, that lets us describe and calculate these shapes with some real precision.
Okay, so let's get into it. Our toolkit really starts with two key ideas that sound kind of similar but are totally different: sectors and segments. And trust me, getting these two straight is the foundation for everything else we're going to talk about.
All right, first up is the sector. The absolute easiest way to remember this is to think of a perfect slice of pizza or cake. It's that wedge-shaped piece that goes right from the crust all the way to the very center of the circle.
And this picture shows it perfectly. See those two straight sides? Those are the radii, stretching out from the center, which is O, right to the edge. And they're connected by that curved part, which we call an arc. That whole shaded bit, that's your sector. Okay, next up in the toolkit, the segment. Now, if a sector is the whole pizza slice, the segment is really just the crust. It's that part you'd be left with if you just made a straight cut across the slice.
And you can see it right here. A segment is the area locked in by a chord. That's the straight line AB, and the arc it connects to. Notice how it doesn't involve the center of the circle at all. It just chops off a piece of the edge.
So here's the bottom line. The thing to remember, a sector is a wedge, and it's always defined by the center point. A segment is that curved slice cut off by a straight line that doesn't go through the center. One's the pizza slice, the other's just the crust. Okay, so now that we can actually name these shapes, this is where the fun really starts. How do we calculate their area? How much pizza are we actually getting here?
The logic for finding the area is actually super clever and really simple. It's called the unitary method. So we all know the area of a full 360-degree circle is pi r squared. So what we do is we just divide that by 360. That gives us the area of one tiny 1-degree slice. Then all you got to do is multiply that by whatever angle your slice actually is. And boom, that gives us the master formula for the area of any sector. That little symbol, theta, that's just the angle at the corner of our slice. You just plug in the angle and the radius, and you've got the area. It's just a beautiful, direct piece of math.
So what about the segment, the crusty bit? Well, it's just as straightforward. You start by calculating the area of the whole sector it came from. Then you just subtract the area of that leftover triangle part. What's left over? That's the area of your segment. Simple as that.
So, we've talked about lines that cut through a circle. But what about lines that don't cut through it, but just, touch it? This is where things get really, really interesting. Not just for physics and engineering, but for understanding motion itself. This is basically the start of calculus.
So a line in a circle can do one of three things. It can miss it completely, it can slice right through it at 2 points, we call that a secant, or it can do something really special. It can touch it at exactly 1 point, and we call that a tangent.
A tangent is a line that just perfectly skims the edge of a circle. The name itself actually comes from the Latin word tangere, which means to touch. Kind of cool, right? It doesn't cross inside, it just makes this single perfect point of contact and then keeps on going. Now here's the really cool part, the golden rule of tangents. It's a huge theorem in geometry. A tangent line and the radius that meets it right at that point of contact, they will always form a perfect 90-degree right angle. Every single time. Always. You actually see this principle in action all the time. Just think about a bicycle wheel rolling on the ground. The ground is the tangent line, and the spoke touching it is the radius. That perfect 90-degree angle is what keeps the ride smooth and stable. It's the same idea that lets a belt transfer power from one pulley to another inside an engine. All right, let's put it all together. Let's use our new toolkit, sectors, segments, tangents, and go solve the puzzles we started with. Let's see how this math actually works in the real world. Remember our grazing horse from the beginning? It's tied to the corner of a square field, so the area it can graze is a perfect quarter circle. Hey, that's a sector with a 90-degree angle. Now, with our formula, we can figure out exactly how much grass that horse can eat.
And this math, I'm telling you, it is everywhere. It's what engineers use to design the sweep of windshield wipers. It's how you calculate the coverage area of a lighthouse beam. It's even used by artisans who are making these beautiful, intricate designs in jewelry and furniture.
So, the next time you see a slice of the world, whether it's a rainbow or a pizza or the beam from a flashlight, you'll know the beautiful, simple math that's defining it. And that leads to one final thought for you. We know a tangent line is always perpendicular to the radius. So using just that one rule, can you figure out why two tangent lines drawn from the very same point outside a circle have to be the exact same length? The answer, well, it's just pure geometric elegance.